Welcome to another video for Ivy Tech Community College, and in this video we're going to be working on another Solidworks project, which you can see here. We're going to be working on this piece, which is called a spacer. So we're going to work on modeling it, and then after we model it up with the necessary design intent, we're going to put together a drawing page with some dimensions and some different drawing views so that we could give this to somebody else if they wanted to manufacture it for us. So the first thing I want to do is kind of look at the part and then read through the design intent so we sort of understand how this part is supposed to behave when we model it. Remember that design intent is added to a part when you 3D model it so that if you change a dimension, it will basically redraw itself or behave in a certain way when you change that dimension. The reason this is done is so that when parts are modeled, they can easily be changed to add additional part numbers, or if you have multiple variations of a single type of part, you can easily create them all just by changing a couple of numbers, and you don't have to remodel the entire part from scratch every time. You could make a new part number or a new part variation simply by changing one dimension, and the rest of the model would then redraw itself. So that's one of the purposes of design intent, and then there are many others as well. So for this particular part, they tell us that the origins should be at the center of the part. So we want the origin to be right here in the middle of these concentric circles. And then as far as depth, we want it to be right here in the center of the part when we model. They also tell us that as the 2-inch diameter feature increases in size, so as this dimension increases in size, the 1.5-inch diameter feature right here should increase proportionally. So we're going to make an equation that makes this relationship always hold true, or in other words, we always want this dimension here to be 75% of this one, whatever this is. So for instance, if someone would change this dimension to 4, we want this to automatically update to 3. Okay, so basically this dimension is going to be controlled by the 2-inch dimension. Then if we go down, they have a couple of more stipulations here. They say that we're supposed to use a revolved feature, and then they give us kind of a tip here that we can dimension from visible lines to center lines to get diameter dimensions. So the way that I'm going to do this is with a revolved feature like they ask. So I'm going to basically sketch out half of this part, but I'm not going to sketch it with these removed sections. So I'm going to start by sketching it and assume that the whole thing is there. Then I'm going to go back and do 2 cutouts. I'm going to do a cutout over here for this kind of rectangular notch, and then I'm going to do a cutout on the top here where they've removed this section. So to start with, I'm going to assume that this is still here and that this cutout section is still there when I revolve it. Then I'll go back and cut those 2 pieces off at the end once I've got it revolved. So starting out, I'm going to basically draw this cross section and dimension it and then revolve it around the center line. So starting out, let's just make a new part. We'll hit OK. And then you want to make sure that you're in inches. Remember, you can change your measurement system really easily in SolidWorks down here between millimeters or inches or whatever measurement system you have. And then I'm just going to go ahead and jump right into a new sketch. And I'm going to go ahead and draw on the front plane when I do this. Okay, and then I want to try and keep this thing centered up as I draw it, but I'm going to start by just making a center line that goes right through the origin. So notice these 2 red arrows indicate my origin, where they come together. So I'm just going to drop this down and choose the center line tool, and you can see my line type has changed. I'm just going to draw a center line right across there, and then I'm going to go ahead and sort of sketch out the basic profile of this part. And then I'll dimension it later to fix it. Oops. A little practice with the line tool here. So again, that's why we're doing this. If it's been a little while since you've used SolidWorks, this is a great practice part where you can kind of get your skills back up to speed. And I'm going to go ahead and close in the bottom down here. Okay, so I'm going to go ahead also and put a vertical center line in here just to make sure that I'm keeping everything centered up. I may not end up using it even, but I'm going to go ahead and just include it. Just like that. I'm actually going to bring this back to where it touches the midpoint or the origin. And I'm also going to make these symmetric, or actually let's do it this way. Let's just bring these back to here where they hit. Okay, now I'm going to start doing some constraints. So I'm going to say that I want these two lines to be symmetric around this axis. And same thing with these two. I'm going to make them symmetric around that axis. I want to make sure that these are collinear. So for instance, if I drag this, notice how it's not matching up to the one over here. I'm going to force these two to be collinear so that they're always in line with each other. So I'll use my collinear constraint, and now you can see that they sort of behave together or follow each other. And these move in and out like we want, and these do as well. Okay, so we're trying to get this thing to behave in a certain way before we even dimension it. So now I've got sort of the proper behavior here, so I can start putting some dimensions on this particular drawing before I revolve it. So going back, I know I need the total length to be 3.75. This should be 2, this should be 1.5. So let's go ahead and do a little dimensioning here. So I'm going to go to my Smart Dimension tool. The whole thing we know should be 3.75. So I usually like to put the biggest dimension on first, and that allows Solidworks to rescale the drawing. I'm going to put on the dimension of 2 here, which, remember, I'm just dimensioning to the center line, so instead of dimensioning to 2, I'm going to cut this value in half, and for my drawing this is going to be 1. Okay, and I can dimension the width from here to here, which we can see is 0.75. So I'll dimension from here to here, and we'll call that 0.75. Notice it stays symmetric, and that should be the only dimension we need now except for this. So let's go ahead and set that up. So we want this to always be 75% of that one. So I need to lock in basically the diameter of this, and the diameter of this is going to be controlled by this. So to do that, we need to basically give this a global variable, or we're going to give this dimension a name essentially. So if I click on this, down here where it says 1 inch, I can hit equals, and I'm going to call this dim1. And that basically tells Solidworks the name of this dimension is dimension 1. Okay, I can come up with whatever name I want for it there, but I like to use dim. I think it's easy to remember. So I'm going to call that dim1 and hit the green check mark, and Solidworks tells me, is it okay to create a new global variable named dim1? Which, yes, I want that, and I actually don't need to see this menu again, so I'm just going to hit that and say yes. And now if I hit the globe right here for the global variable, I can toggle back and forth and see that this dimension, its size is 1 inch, but if I hit the globe, it tells me its name is dim1. Okay, so that's going to become important here in just a second. So I'm going to hit OK on that, and you can see that has a global variable attached to it because it puts a sigma, or a Greek letter S, in front of that dimension. So I know I have a global variable now attached to this dimension. Now if I come back over here and I dimension this size, instead of putting a number on there, I'm going to put an equation in here where it will calculate the size on its own. So instead of changing this number like you're used to, I'm going to say equals. And I'm going to come down to my global variable, and I'm going to say I want this dimension to equal dimension 1 times 0.75, or in other words, I want this measurement to always be 75% of this one. So I'll hit OK there, hit OK again, and you can see that it changes its size to 0.75. But if I go over here and modify this, so for instance, if I change this to 1.25, now this redraws itself at a new correct size. So this dimension will always update itself based on this one. Okay, so we can sort of see the rough shape that we're looking for starting to come out here. So I'm going to go ahead and change this back to 1, hit OK, let it update, and we should be ready to revolve here. So I'm going to go ahead and back out of the sketch, and I'm going to go to my revolve feature right here, revolve boss base, and I need to choose the cross section that I'm going to revolve, which is going to be this sketch. And then I need to choose my axis of revolution, which is actually going to be this line. So notice it chose the wrong axis of revolution, but I can easily fix that. So make sure that the correct axis is in here always. Sometimes SolidWorks will guess wrong. So I went ahead to go in there and patch that up. You can put in your rotation angle here if you need to, but mine's 360 already, which is what I want. So I'll go ahead and OK that. And there we kind of have the rough shape for this part. Next, we're going to go ahead and put these cutouts in. So let's go ahead and do a new sketch. And I'm going to do the easier of the two. So I'm going to start by putting the square cutout kind of over here on the end. And we can see that square cutout is 0.5 wide, and it goes through the whole height of the end of the part. So I'm just going to do a sketch right here, just a new sketch. And I'll do a control space to lock right onto that view. And I'm just going to draw a circle right on top of here. And then I'm going to do a center line all the way through that circle. Okay, and then let's see if we can offset these. Okay, so I'm just going to offset that each way. And then I know I want a total of 0.5, so I'm going to make this 0.25. I'm going to take this dimension off. I'm actually going to make these two symmetric around this vertical center line. So now this way they always stay centered up, and I only have to change one dimension. So I can alter this dimension now, and they'll always be centered and equally spaced. Okay, so that gives me a total width of 0.5. I'm going to do some trimming now and trim off the edges of these arcs, clean up my endpoints down here. Okay, then we just need to adjust these. So I actually want to make this and this co-radial. So I'm going to take these two arcs on the end if they're not defined, if they're still blue, and I'm just going to say take these arcs on the end and make them co-radial with this shape so that they will always match up. So that design intent will make sure that I never have to go back in and fix these arcs. They'll always match up to whatever this size is. And this size is calculated based on this one. So now I've got some design intent going where if this size changes, and this arc will automatically change itself too. So I'm never going to have to go back in and patch up any line work. So let's go ahead and back out, and we'll do a cutout here. Whoops. Let's do an extruded cut. Make sure you choose the right option there. So we'll do an extruded cut, and it will automatically pick on mine the correct section. So I just need to know how far to cut in now. So if I look at my drawing, we can see it's a 1/2 inch wide, and it's going to be a 1/2 inch deep. So the depth of my cut is going to be 0.5. So I'll go ahead here and change that and OK it. And then just make sure everything looks good there. It looks like that cut worked correctly. So now I'm going to jump over to this side, and we're going to cut off that flat section that you see right here. So that cut should actually be 1.5 inches deep, and it's 1/2 inch up off of the center line. So I'm going to do a sketch on this end right here. So I'll do a new sketch and then do a control space so I can look right at it. And I'm just going to draw a circle that is concentric here with the origin. And I'm actually going to say that I want this and this to be equal in size. Let's try co-radial. It's not going to like that either. So let's just delete that. And instead, let's convert that entity. So let's take that circle and we'll just convert it as an entity into our sketch. And now we can just use it. Okay, so that looks a little bit better. So now we're going to go a 1/2 inch up off the bottom. So I'm going to draw my center line in here and then trim off the edges. And then I'm going to offset that up this direction by 1/2 inch. Okay, now I've got that section that I want to cut out right here. So if I trim this off, trim this, and then trim off this circle that we put in the back, Now I've sort of boxed in this section up here at the top, sort of this semicircle that I'm going to cut off. And when I take this, if we look at it isometrically, if I take this and cut it back in, that's going to give us this cutout that we're looking for. So I should be able to take that profile that I sketched and cut it out 1.5 inches back now. So let's OK this sketch and go back. And we're going to go to an extruded cut again. Here's my cross section that I'm cutting out. And according to our print, I should go back 1.5 inches. So I'll accept that. And I'm going to say that we have an error there. I have not looked at the print correctly. So I go 1.5 inches plus I have to go another 3/8 of an inch, or another 0.375. Okay, so make sure you double check your print. So mine was not looking correctly because I read the numbers wrong. So let's say instead that that should be 1.5 plus 0.375. And that's going to look better. So let's go ahead and OK that. And that's what our part should look like. And I also think it would be neat if we could go ahead and set the appearance of this part to match what's in our PDF here. So we're going to change the color of this part. They don't tell us what the material is, so we're just going to change the color of it, but it would be neat if we could make it match what we see here. So I'm going to come over here and just right click at the very top of my my feature tree manager, and if I drop this down I can come down to appearance. So you could set the material down here if we knew what it was, but we're just going to change the color. So I'm just going to go to appearance, and then I can change the color here, and if I come over to my color selection, I can kind of go around until I get sort of the same green color that we see in the handout. So I'm going to say it's kind of like that. And then I'll just hit the green arrow up here, or the green check mark, to select that. And now we have a part that resembles the handout a little bit more closely. Okay, so I'm going to go ahead and save this. I'm just going to throw it on my desktop for right now. Or let's go ahead and put it on the flash drive. And we're going to call this one Lab B. If we're doing this for Design 272, if you're doing this for another class in the future, you can name it whatever name you need, but I'm going to go ahead and call it Lab B for right now. And we'll hit save. Okay, and there's our part. So now we're ready to go ahead and put together our drawing page since we have our part all modeled up. So I'm going to come up to New, and this time we're going to choose a drawing and hit OK. And right now it's set up for metric page sizes. So this A0, A1, A2, A3, these are metric page sizes, which you can see here where it says ISO or ISO. If I uncheck this, this will give me US customary or ANSI paper sizes also. So your regular 8.5 by 11 computer paper that you're used to is this ANSI A paper size. So I'm going to do an A ANSI landscape, which you can see here is 8.5 by 11. So I'll hit OK on that. And we don't really have a standard title block right now, so I'm just going to go ahead and sort of clear this out. We're just going to put a border on this drawing and not really worry too much about a title block right now. But I don't really like this standard SolidWorks title block very much because it takes up so much page space that you really don't have any room left for your drawing views. So I'm just going to come over here in my feature tree, and I'm going to right click this sheet and go to Edit Sheet Format. And what that's going to let me do is it's going to allow me to edit this title block. So I'm basically going to drag select and delete all this stuff except for the border. I want to keep that. But all the rest of this stuff I'm just going to delete out of here just with some selection windows. So just kind of highlight everything and get rid of it except for your border. We'll go ahead and leave that in there to keep things looking nice. Okay, and then when you get that all cleaned up, you can just return back to your drawing and it'll gray out that border. So now we'll just get a nice border that will print out there. So I'm going to come up to my view layouts now, and I'm going to go ahead and do a standard 3 view for my part, which you can see is open here. And let's see if we can change some scales here. I'd like that to be a little bit bigger. So let's try using a custom scale. Let's try going with a 1:1. I think that we can make that work still and have it fit on the page. So that looks pretty good, and I'd like to have an isometric on here also, so I'm going to project an isometric view up. But I'm going to shrink it down just a little bit. I'm going to make it probably a 1:2 scale still. So I just want to give it up there as a pictorial, and I'm going to change its view style also. So just so people can kind of see it and get a better idea. Okay, now we need to put a couple of center marks on here. So I'm going to go to Annotate and Center Marks. And we'll just put one right there and hit OK. And then we'll just add a center line also. Let's try that again. Let's go to center line. And I'm going to go to auto insert and let's select this view. I like the auto insert option sometimes. It's not doing a very good job for us though, so let's just manually put this one in. So we'll just pull that down. There we go. And then we'll do up here also. Okay, so we'll just do a double click there and add that one in and hit OK. So there we've got all of our center lines and center marks. And let's see if we can add some hidden lines here. So I want to show my hidden lines, so I'm going to change my parent style for this view. Right now it's just set on visible lines, but I want to show hidden lines too. So let's go ahead and include those. That way we can see the hidden lines everywhere like we would expect. And finally we just need to put some dimensions on here. We've got it looking pretty nice. We've got our colored isometric view. We've got our 3 orthographic views modeled correctly with all of our hidden lines, our visible lines, our center lines. So let's just go ahead and do a couple of dimensions. Just the Smart Dimension button will be fine. And what I would recommend to you is we basically just go through and redo the dimensions that you see right here. There's no reason to complicate this. So back in our drawing, remember to dimension features where they're visible at. So for instance, the 0.5 I would dimension right here. That's where it's visible. The total length I would dimension down here. That's where that is visible. I would prefer to dimension my circular features over here where they are visible. So try to dimension things where their shape is, clear and obviously present. So we'll just go through and dimension this real quick. And let's see what we're missing here. We've obtained those two. We need to get our height dimension there. The depth for our cutout we've placed. So let's go ahead and put this dimension up here. And this dimension is useful also, so we'll go ahead and place that one. And then we probably need to put this dimension on also to prove that the part is symmetric. That's always a good idea. And then finally we probably need to put one more dimension on there for this section right here. Okay, so there we've got some dimensions. So basically for that part you can go through and replicate the dimensions that are on the handout that I gave you, but make sure you don't repeat any dimensions and that you have all the dimensions you need on there. So that's basically a quick review drawing in Solidworks to give you some practice with some of these commands and look a little bit more at using global variables to dimension our parts and include design intent, and also a little bit more practice with creating a drawing page with views and dimensions and hidden lines and center lines. So go ahead now and model this part on your own, or hopefully you did it on the way through, and also create your drawing page for this when you get done. And then when you get both of them done, the model and the drawing page, you can upload those to our Dropbox in Blackboard in the appropriate week by week folder, and you'll be good to go. So if you have any questions, feel free to contact me. My email is jhamilton83@ivtech.edu. So good luck, give it a try on your own now. Let me know if you have any problems, and I'll see you around.